Sec 1, Chapter 10.2, Part 2, Sequences. Now, in this part of the chapter, we'll be learning on the formulas to find general terms of a sequence, and we will solve problems involving sequence and number patterns. Linda draws a pattern of dots to form a sequence, so we notice that pattern 1 have 5 dots, pattern 2 have 8 dots, pattern 3 have 11 dots. So now how do we get 8 from 5? We add a 3. We add a 3 to get 11. And what will be pattern number 4? We add a 3 to get 14 dots. So pattern 4 will have the number of dots to be 14 dots. And in pattern 10, now, in order to find pattern 10, let's analyze a little bit of a pattern. When it's pattern 2, I add 3 one time. When it's pattern 4, I add from 5, 3, 1, 2, 3 times. So I'm taking 5, I add 3 times when it's for pattern 4. If I were to have to find pattern 10, that means I'm going to take the number 5 plus a 3, but since it's pattern 10, right, so I've only added 3 9 times, and that will give me the total number of dots to be 27 plus 5, 32. 32 dots. Now part B, write down expressions in terms of n to find the number of dots found in pattern 10. Now, in order to get the number of dots in pattern n, I need to analyze a little bit. This is adding a common difference of 3. So actually we have two different methods. Method number 1 is to use the formula a plus d bracket n minus 1 for your pattern n. That means my a is the first term, which is I take 5. I'm adding a difference of 3, and in order to find n, it will be n minus 1 times. Now, can we leave this as the final answer? No, we need to expand and simplify. So after expansion, we will have 5 plus 3n minus 3, and that gives us 3n plus 2. Next, for method 1, if you want to try method 2, we'll know that, I'm adding a common difference of 3, so my formula will definitely start with 3n. But 3n, let's say when n equals to 1, this is 3 times 1. What do I need to add in order to get the number 5? So I'm going to add a number 2. So therefore, my pattern will be 3n plus 2. Have you gotten the answer? Now part C says that which pattern? If it's which pattern, do I know the n term? I do not know which is the n, right? But they tell me the pattern n will give me 3n plus 2. So that means pattern n will have how many dots? 2, 3, 3. So my pattern n will have 3n plus 2 dots. And I know that the number of dots is given to me now to be 2, 3, 3. Can I find what is this n, the pattern n? So what am I going to do now? I'm going to group the like terms together. So 2, 3, 3. I'm going to have 2 to migrate over. That will become minus 2. 3n is equals to 2, 3, 1. And now let's divide by 3 to get the number n. And I got my answer to be 77. Which pattern is made up of 233 dots? So it will be pattern number 77. Have you gotten the answer? Example 8. This pattern is made by drawing squares. I have originally 1 square, and now I added 1, 2, 3 more to get the side to it. and then now I have 1 2 3. Here got 1 1 2 3. Here I have 1 2 3 4 5. So what will be pattern 4? Pattern 4 will have 7 squares. Oh my god. 1 2. Oh, not enough space. Okay, let me write smaller. 3 4 5 6 7. 1 2 3 4 5 6 7. Then I will slowly build up until I get 1 square. Yes, 1 square. Am I right? Yes. So this is pattern number 4. Now let's do a little bit of counting. They want to complete the table below. The pattern number is 1, and then I have 1. 2, pattern 2 have 4 squares. Pattern 3 have 9 squares. Do you find this a little bit familiar? So pattern 4 will have how many squares? Have you counted? Well, my guess is it's going to be 16. What do you think will be the number of squares for pattern 5? Well, it's going to be 25. Have you found the pattern? This is actually made up of 1 square, 2 square, 3 square, 4 square, and 5 square. So write down an expression in terms of n for the number of squares found in pattern n. So if I have pattern n, then my number of squares will be n square. Term n to be n square. How many squares are there in pattern 50? That means I'm looking at term 50. Now my n now becomes what number? Term 50, n is now 50 square. So 50 square gives you 2,500. Yes, correct, 2,500. Then they ask you a nice question. Which pattern has 784 squares? What is my pattern given? My pattern says that Tn is n squared. So I do not know which pattern, but what is the number of squares that it has? The number of squares is 784 squares. How do you think I can get rid of the square in order to find n? What is the opposite for square? Well, it's the square root. So n will be the square root of 784, and it will be 28. So which pattern has 784 squares? That will be pattern number 28. Part F. Is there a pattern that can be formed using 1,000 squares? Okay, let us say, for example, right, if the number is 1,000 squares, and that will be equals to n, let me see if I can find a pattern n that has 1,000 squares. That means there is such a pattern. If I cannot get the value of n, then there isn't such a pattern. So how do I find n in this case? How do I get rid of the square? Well, we got an answer, which will take square root. So n equals to square root of 1,000. Square root of 1,000 to give you the number. Oh, this number is 31.622 something 23. Can I have a pattern? Pattern 31.623? No, right? So that means, what does it tell us? Is there such a pattern? That means there wouldn't be such a pattern. But what's the reason? Because n is not a whole number. Or rather, I should say, to be more accurate, n is not a integer. So since n is not an integer, therefore there is no pattern with 1000 squares. So this will be the explanation. Have you gotten the answer? Question number 9. Consider the following pattern. They asked me to write down the following pattern and then write down the 4th and the 8th line. Now let's take a look. This number starts from 1, then 1 cube, then 1 cube plus 2 cube, then 1 cube plus 2 cube plus 3 cube. So what will be line number 4? It will be 1 cube plus 2 cube plus 3 cube plus 4 cube. Okay, and then I do not know what is the number, but it tells me this is 1 square, 3 square, 6 square, and then what do I need to do? So that means I need to count this number first, right? Probably. So 6 is made out of 36 square. So I'll have 1 cube plus 2 cube plus 3 cube plus 4 cube to give me the number 100. So that means 100 will be what number square? Will be 10 square. Okay, so let's try. If that's the case, line number 8, I will have a 1 cube, 2 cube, 3 cube, 4 cube, 5, 6, 7, 8 cube, and that will give me the number 1296, and this number is equals to what number square? Well, that means we're going to take the square root of 1296, and that gives me the number 36 square. So that means this will be line 4 and line 8. Now we have not finished analyzing this pattern yet. I know how to go from this pattern to reach the number, okay, 10 square. But how, if I'm given 10 square, how do I reach all these numbers over here? Right? So let's find a link. I have the number 1, and this is 1 square. I have 1 plus 2, and it gives me the number 3. 1, 2, and 3, and gives me the number 6. Now let's try, if it's 1 plus 2 plus 3, that gives me number 6, isn't it? Well, let's try. 1 plus 2 plus 3, that's 6, plus another 4, that's 10. Okay, 1 plus 2 plus 3, that is 6. 6 plus 4 is 10. 10 plus 5 plus 6 plus 7 plus 8. Does that give me 36? Let's check. Hey, yes, it gives me 36. That means if I'm going to analyze the next line to find P and Q, what does it tell me? The first part is quite easy. I'll do the 441 over here. 441 equals to something square. What number square is this? So I'm going to take square root for 441. Okay, write down an expression for Q square. So 441 will be what number square? Square root of 441 will give me the number 21 square. So we know that Q square is equals to 21 square. So if that's the case, what is the expression going to be for P on this side? That means I'm going to start with something that's added and until it will give me 21. So that case, I will have something less. This is 21, right? This is 26, right? So it must be something lesser than 8. So never mind, I should try. I'll have 1 plus 2 plus 3, that is 6 already, plus 4, that's 10, plus 5, that's 15. 15 plus 6, that will be 21. So this will be the answer. So what are the expressions for P and Q square? P is 1 cube plus 2 cube plus 3 cube plus 4 cube plus 5 cube and 6 cube. and Q square will be the expression 21 squared. Have you gotten the answer? Exercise 10. The figure below shows a sequence formed using triangles. Now you notice there are black and white triangles. So we have a black triangle in the middle, and then it's surrounded by white triangles at the sides. So they asked me to draw the next figure. So originally I have one black triangle, now got two. Pattern number 3 have 3 black triangle. So pattern 4 will have 4 black triangles. Okay, so you have something like that. And then it's surrounded by white triangles on the top. So I have 4 white triangles. Okay, so now I've drawn the next figure already. This is figure number 4. Copy and complete the table below. The number of black triangles when it's figure 1 is 1 black triangle, 2, 3, 4, and that means figure 5 will have 5 triangles as well. The number of white triangles, they gave me a particular pattern. This is 2 times 1 plus 1 equals to 3. 2 times 2 plus 1 equals to 5. What do you notice is the one that changes? Or rather what stays the same? Now according to my pattern, 2 times something plus 1 equals to another number. So what is that something? So if it's figure 4, then it will be plus 4. 8 times 4. 2 times 4, 8. 8 plus 1, 9. Then for figure 5, it will be, I'm going to follow the pattern. It says 2 times something plus 1. And since it's figure 5, though, this will be 2 times 5, which is 10. 10 plus 1, 11. Okay, write down an expression in terms of B for the number of white triangles. Where's the B? That means, the number of white triangles here is related to B. So when B is 1, do you see any of it appearing here? Oh, this is 1. When this is 2, here's 2, 3, 4, and 5. So that means if I want an expression in terms of B for the number of white triangles, it tells me I will follow this pattern. 2 times the number of black triangles, which is B, plus 1 to give you the total number of white triangles. Okay, so since they only want expression, not equation, so I should write this down as expression. If a pattern has 45 black triangles, how many white triangles are there? So I'm going to use my formula that's given to me. If there are 45 black triangles, so now the number here B changes to 45. How many white triangles are there? So I'm going to calculate part D, number of white triangles, is equals to taking the formula 2 times, there are 45 of them, right? 45, which is 90, and then you plus 1, that gives you the number 91 white triangles. The other way around, if I were to give you that a pattern has 77 white triangles, so that means this whole expression here is now equals to 77. So I will have 2 times B plus 1 to give me 77 white triangles. So our objective, find how many black triangles are there. So now I'm going to group the like terms together. So 77 minus 1, that gives you 76. 2B is 76, divide by 2 will give you B to B. Taking 76 divided by 2, that is the number 38. So there will be 38 black triangles. Have you gotten the answer? Exercise 11. Consider the following sequence. Oh, the numbers are also big. I'll start with the number 27, 64. 27 looks very familiar. And all these numbers are increasing by a very large amount. So probably I should not be looking at a common difference. Instead, I should be looking at either perfect square, perfect cube, or even power form. Perfect cube. Now I can link this. This one is actually the number 27. 27 is made up of 3 cube. If that's the case, what's 64? 64 is actually 4 cube. 125 is 5 cube. So this should be 6 cube. And let's check out, is this 7 cube? So 7 to the power of 3. Yes, this is 343. Now in this sequence, so we know that something cube already. So what's the number that's changing? So we have 3 change to 4, 3 change to 5, and 5 change to 6, 6 change to 7. This is the first term, second term, third term, fourth term, and this is the fifth term. Okay, so what does this mean? This means that if I want to find a general term, this general formula will be something cube. But before we find something cube, we need to find the relationship to get the number, the pattern 3, 4, 5, 6, 7. So I should use my formula. Formula says a plus d n minus 1. So for the n term, to get the number over here before you cube it, that will be, Tn will be, taking the first term, which is number 3, I add a difference of, in this case we are all adding 1, right? Plus 1 plus 1. So I add a difference of 1, but n minus 1 times. So let's take a look, okay? So this will 3 plus, expand out our brackets, n minus 1. And that gives me the formula n. 3 minus 1 will give me n plus 2. If the number over here is given by a sequence of n plus 2, that means the general term to get this series of number will be, I take n plus 2. Okay, I shall call it pattern n instead. So that I do not mix them up. I'll take this one over here, n plus 2 holding square. Okay, and I can get my answer. That's method 1. Or I can do method number 2. I know I'm adding a difference of 1 unit, so the formula will start with n plus n anyway. But when I have the first term will be n equals to 1, so it will be 1 plus something to give you the first term over here, 3. So that means it will be 1 plus 2. So that means this will be n plus 2. And hence we can also get our pattern for the 27, 64, 125 to be n plus 2 holding cube. Okay, so Pn equals to n plus 2 holding cube. Hence, so I'm going to use this pattern. Find the 12th term. So the pattern for pattern number 12, n now becomes the number 12. So I'll use this pattern. That will be 12 plus 2 holding cube. So it's 14 cube. That gives me 14 cube to be 2744. Have you found the answer? Consider exercise 12, the sequence 1, 5, 9, 13, 17. Okay, these numbers are increasing steadily. So I have 1 plus 4 to give you 5, plus 4, plus 4, and plus 4. So to find the general term Tn, I know that I'm taking the first term, which is 1, plus the difference n minus 1 time. So it will be a plus d, so a is 1. Difference is 4 times n minus 1 times. So let's expand and simplify, and we'll get 4n minus 3. Or method number 2, you can say that, oh, I'm adding 4, so it'll definitely be 4n. But when n equals to the first term is 4 times 1, plus what number to give you the number 1? So in this case, have to be 4 minus 3 to give you 1. So my pattern will be 4 minus 3. So therefore, Tn is 4n minus 3. Have you gotten the answer? Part B say hence, find the 50th term. So I'm going to use this formula T50. That means n now changes to the number 50. 4 times n, 4 times 50, 200. Minus 3, 200 minus 3, that gives me 197. Have you gotten the answer? Exercise 13, part A. Write down the 12th term in the sequence. What do you notice down here? I have 25, and then it dropped to 22, and dropped to 19, and dropped to 16. It looks like it's decreasing, right? So from the number 25, I subtracted 3 to give me 22. I subtracted another 3, and that gives me 19. Subtract another 3, that will give me 16. They want us to find the 12th term, but before I find the 12th term, I'll know that this is actually a series that starts with the common difference. So if I were to use my formula, Tn will be actually taking the, or maybe I don't find Tn, I can just directly find the 12th term. Okay, T12, that means I'm going to take from the first term, okay, which is the number 25, I'm going to subtract 3. Normally it will be, if this is n, then this will be n minus 1 time, right? But now the n is actually 12, so it'll be 12 minus 1 time, which is 11 times. So that means I'll take 25 minus 33. 25 minus 33 will give me negative 8. So term 12 is negative 8. Part B. Write down an expression in terms of n for the n term in this sequence. I have the number 9. Hey, 9 is 3 square. 16, 4 square. 25, 5 square. 36, 6 square. So there is quite a link down here, right? It's a series of perfect squares. But my pattern is starts from 3, it goes to 4, 5, and 6. So in order to have something square, let's find the pattern for the 3, 4, 5, 6 first. It goes in consecutive numbers. My first term starts with 3. I added a 1, n minus 1 times to 8. So I shall call this Tn. And that will be 3 plus, need to expand out first, n minus 1, which is n plus 2. That means Pn, this series, this pattern will be taking this number n plus 2. What do I do to it? I need to get square, 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 right? So square this whole thing. Okay, so this will be pattern n. Or alternatively, instead of that, I know the common difference is plus 1, 1 unit. So it'll be n, 1 unit of n. So when n equals to 1, it'll be 1 plus what to give you the number 3. So 1 plus 2. So this will be plus 2. So therefore, Tn is n plus 2. And this one will be n plus 2 holding square. Have you gotten the answer? Now, before we end off this whole part of the chapter, we are left with the homework questions. Exercise 10.2, questions 6 and 7. We'll continue with the next lesson to go through the answers. See ya!